We're now going to review one of the most important rules in all of mathematics, the order of operations agreement. In arithmetic, we have four operations: add, subtract, multiply, and divide. What happens when more than one of these operations occurs in the same problem? Which operation do you do first, second, third, and so on? This order of operations agreement is particularly important nowadays because it's the order in which computers perform their work. Be very, very careful as you work through this portion of the tape. Watch closely for using all of the rules that we've learned for adding, subtracting, multiplying, and dividing rational numbers. Watch for the exponents, which we've just been over, and pay attention to how all of these things fit together. All it takes to mess up a math problem is one small mistake. These problems are lengthy, they require a lot of writing, there are many opportunities for you to make a mistake. So be super careful this time. Let's recall the actual order of operations agreement. You've learned this in the past, so let's go back over it. Remember that the order of operations agreement has four parts. Part 1 says, work inside grouping symbols from the inside out. Work inside grouping symbols from the inside out. We have several grouping symbols. One is parentheses, a second is brackets, which look like squared parentheses, braces, which are the fanciest one, and a fraction bar. The fraction bar may not seem like a symbol of inclusion, but if you have more than one thing to be done in a fraction, that is, pretend that you have, say, 2 plus 3 in the numerator, and maybe 12 minus 6 in the denominator. The fraction bar says, do the part in the numerator and do the part in the denominator as if they were written inside parentheses. After you finish the grouping symbols, step 2 is to do exponents and radicals, left to right. We have not worked with radicals in this unit, and we don't plan to in this unit. I'm giving you the order of operations agreement that is used for all of mathematics. In many other places in mathematics, radicals occur, and when they do, they are paired up with exponents. A radical, like a square root, is the reverse of a power, like the square, and they should indeed go together. So step 2 is do exponents and radicals, left to right. Then we get to the operations of arithmetic. Step 3 is do multiplication and division, left to right. Do multiplication and division, left to right. And step 4, do addition and subtraction, left to right. Notice that the order of operations agreement has 4 parts. The 4 parts are work inside grouping symbols, then do exponents and radicals, then do multiplication and division, finally do addition and subtraction. The 4 operations of arithmetic have been paired up. The multiplication and division go together. The addition and subtraction go together. Let's look at an example where we have to be aware of this pairing up. Our first example says 2 to the 4th power divided by 8 times 2. 2 to the 4th power divided by 8 times 2. Notice that there are no grouping symbols, and so we go past the first step in the order of operations to step 2, which says do exponents and radicals. We have an exponent, 4th power, and so we do that first. 2 to the 4th power means 2 used as a factor 4 times, 2 times 2 times 2 times 2, which is 16. 16 divided by 8 times 2. Now we have divide and multiply. Which one is done first? you should answer that divide is done first because divide and multiply come in the same step and we do them from left to right. Since divide comes first as we read from left to right, we do that first. And so we do 16 divided by 8, which is 2, then times 2 is 4 for our answer. Next example, this is a bit longer. 13 subtract 12 times, in parentheses, 9 subtract 4, divided by 2 to the second power. 13 subtract 12 times 9 subtract 4 divided by 2 squared. Where do we begin? Well, we must begin inside the parentheses. We have 9 subtract 4, and 9 subtract 4 has to be done before we do any of the other procedures. We have subtraction here in 2 places. It would be wise for us to make the subtraction change to add the opposite, so we'll be ready to use the subtractions as they occur. And so let's do that. Let's change to 13 add negative 12 times 9 add negative 4 divided by 2 squared. Change the subtract to add the opposite. Change the subtract to add the opposite. Then we're ready to work the expression inside parentheses. 9 plus negative 4 is 5. Notice that everything else is copied exactly as it is. 13 add negative 12 times, in parentheses, 5 divided by 2 squared. These order of operations problems require a lot of copying. Make sure you don't make a mistake in a copying. That would really be a shame, wouldn't it? And if it happens to you, it's not the first time it's happened to anyone. This is a frequent error. Make sure you don't make a mistake in copying. Now we have add, multiply, divide, and exponent, which is done first. It's the exponent's turn. And so we work out 2 to the second power, which is 4. Everything else is copied as it was in the line before. 13 add negative 12 times 5 divided by 4. Now we have add, multiply, divide, which is done first. The multiplying and dividing are done in the same step, with the multiplication coming first because it occurs first as we read from left to right. So we copy the 13, copy the add sign, and then work the multiplication of negative 12 times 5, which is negative 60. Copy the divided by 4. We have add and divide, which is done first. The divide is done before addition. Negative 60 divided by 4 is negative 15. Now at last we're down to a single operation, and so there isn't any choice. 13 add negative 5 is negative 2.